Okay, we have this rational function, and we want to take the derivative of this and find out what that is. We are going to use the quotient rule. So we are using the quotient rule, and that is because of the rational, the division. Okay, and then we're going to go through that. So here is the first thing we're going to do. So y prime is equal to, now you need to pay attention because there's a little bit of algebra involved. So if you look at the function y originally as f of x over g of x, so we're going to start with the derivative of the top, so will be 2x plus 1, then multiplied by the g of x, the denominator, subtract away, and now we're going to leave the top alone, so that would be x squared plus x minus 2. Now we're going to take the derivative of the denominator, and that would be times 3x squared, and all of that divided by g of x squared, and here it is. Okay, all right, now you're going to go through and do the expansion as much as you can, and then simplify, collect like terms. So let's do that. So here it is after the expansion. Now I just want to remind you, I know this is the high school, more like high school algebra, but be aware when you're multiplying through, you have to do the proper distribution. Okay, one term at a time, and so is this one. So multiply each term at a time, and this negative stays negative, and then you can go ahead and simplify the top. The bottom, the denominator, there is no utility to expanding that. It's not going to help at all in terms of simplifying this rational expression, so we're going to leave it alone. So when we come back, we're going to add all the like terms and subtract like terms. Basically, we are going to simplify the numerator. Okay, and here is the final simplified form of the derivative of the function. Make sure that when you do the negative here, this the negative outside of that bracket, again, algebra, just pay attention to these little details now, because that does make a difference, and that's your final answer. Okay.